Hello everybody. Today we are going to be taking a look at section 5.3 on solving trig equations. So hopefully you guys are getting the habit of taking notes here. I would strongly recommend that you get out your trig table and your unit circle for today, because we will be using those as part of the notes. So we're going to go straight into a question here. So for question number 1, if I say we're going to look at the equation 2 sine x minus 1 equals 0. Now this is not a verify question. We're not trying to prove that this is always equal to 0. So we got to shift our thinking here. Here we're actually trying to solve and find what values of x will make this true. So what I want you to do here for starters is just kind of pretend that this is an old Algebra 1 question. If I just gave you 2x minus 1 equals 0, I'm pretty sure you guys can all solve that. You just move your 1 over, divide by 2, and you're done. Well, this problem starts the same way. I'm going to move my 1 over, and I'm going to divide my 2 over. That's going to get me to the sine of x equals 1/2. So in terms of that, that's the same thing we did in Algebra 1. Now here's where it's different. If I'm trying to get x by itself, the next thing I have to get rid of is sine, and the question becomes, how do I get rid of sine? And that's where the inverse sign comes into play. When I say the sine of x equals 1/2, what I really want to know then is, for x, give me a value of x that has a sine of 1/2. And let's say that I want you to find me all answers that fall in between 0 and 2 pi. Now this is where your trig table or your unit circle, whichever you're more comfortable working with, will help you. I want you to look on your trig table or your unit circle, and I want you to find me the angles in radian mode that have a sine equal to 1/2. So sine is going to equal 1/2 at pi over 6, and sine is also going to equal positive 1/2 at 5 pi over 6. So those are the two answers in between 0 and 2 pi that are going to make this thing true. That will make my equation true. Okay, now there's two ways that I could ask this. If I only ask you to find me the answers in between 0 and 2 pi, you're done. It's pi over 6 and 5 pi over 6. But if I were to say find all solutions, these answers are going to repeat every single time I go around that unit circle. And remember, every time I go around the unit circle would be a distance of 2 pi. So that's why you may see some answers that look like this, because my answer is pi over 6, my answer is 5 pi over 6, but they're going to repeat every single time I go around the unit circle. And one distance around the unit circle is 2 pi, and k is just standing for some integer multiplication of that. So I could go around once, or I could go around twice, etc. Okay, so that's in general kind of what we're dealing with here. So take a look at another example. So for question 2, if I give you 3 tangent squared theta minus 1 equals 0, and I say solve over the interval of 0 to 2 pi, then I'm going to start this very similar to how I started the last one. I'm going to move my 1 and move my 3. That gets me right away to tangent squared theta. All right, that looks really bad. Let me fix that. Tangent squared theta equals 1/3. So now the next thing to get rid of would be the square. And how do I get rid of a square? I square root. When I square root, I have to remember plus or minus. So that gives me the tangent of theta equals plus or minus the square root of 1/3. And I can't have the square root of 1/3, so off to the side here I'm going to fix that. And I can see that that's going to give me radical 3 over 3. So where I'm at now is that the tangent of theta equals plus or minus radical 3 over 3. And now I'm ready to go to my unit circle or my trig table and find every single value where tangent is equal to plus or minus radical 3 over 3. Now, tangent, this is probably easier to do off of your trig table, because if I use my unit circle, I have to do sine over cosine. So if you have your trig table in front of you, I can scan down the tangent column and find all those angles where tangent is equal to plus or minus radical 3 over 3. So that's going to happen at pi over 6 and at 5 pi over 6, and it's going to be 7 pi over 6, and it's going to be 11 pi over 6. Now for this one, since I had only wanted you to find the answers between 0 and 2 pi, I don't have to add anything to it. So this is my block of answers for that question. Okay, let's try this one next. Question number 3. I've got 2 more to do here. So we're going to solve now 2 sine squared x minus sine x minus 1 equals 0. And let's start by doing this one over 0 to 2 pi only. Now, sometimes it's easier to think of this in terms of an Algebra 1 question. This is like having 2 something squared minus the something minus 1 equals 0. Well, we know how to solve that. That's a trinomial. We're going to factor that. So if I was going to factor that in Algebra 1, it would look like 2x times x, and I would need a 1 and a 1. This would need to be minus, this would need to be plus. So then looking at this is the exact same question. It's going to factor the same way, except instead of 2x times x, I need 2 sine x times sine x. Okay, so it's a very similar question. And then I would need a plus 1 and a minus 1. So now I have this times this equals 0. I do 2 sine x plus 1 equals 0. I do sine x minus 1 equals 0. I get sine by itself. Sine x equals negative 1/2. I get sine x by itself here. Sine x is equal to 1. And now, in order to get rid of sine, I go to my unit circle or my trig table, and I find for the first one, where does sine equal 1? Negative 1/2. Well, if I scan down my sine column or look on my unit circle, I can see that sine equals negative 1/2 at 7 pi over 6 and at 11 pi over 6. So those are my 2 answers for that one. Where does sine equal 1? Sine's going to equal 1 at pi over 2. So those are my 3 answers that fall in between 0 and 2 pi. If the question had said find all solutions, I'd do the problem the exact same way, but then I would add a 2 pi k to every answer, because 2 pi is 1 full distance around the unit circle. So if it said all solutions, that would be my block of answers. All right, one more. For question number 4, we're going to take a look at 2 sine squared x plus 3 cosine x minus 3 equals 0. Now, this has a little curveball. We're going to solve this one just over the interval 0 to 2 pi. But here's the curveball for this one. If I think of this in Algebra 1, this would be like having 2x squared plus 3y minus 3, because my variables are different. So I can't solve that in Algebra 1. But in trig, I have identities that allow me to change variables. Hopefully at this point, you're getting more comfortable recognizing your Pythagorean identities. I know that cosine squared plus sine squared is equal to 1. So therefore, when I see sine squared, I can replace that with 1 minus cosine squared. So sine squared came out, I replaced it with 1 minus cosine squared, plus 3 cosine minus 3 stays. And now if I distribute that 2, that gives me 2 minus 2 cosine squared plus 3 cosine minus 3 equals 0. We're going to combine some terms. Negative 2 cosine squared plus 3 cosine minus 1 equals 0. And now I have something that I can actually factor. Now, before I do, I don't like this negative 2 cosine squared, so I'm going to multiply everything by a negative 1 to make that positive. That just means I'm switching the sign of everything. Now, this I should be able to factor with the ma method. If you don't like factoring that, then off to the side write it as 2x squared minus 3x minus 1 if you want. But I'm going to need a 2 cosine and a cosine. And I'm going to need, actually I messed up here. This should be a plus 1 right there, not a minus 1. Sorry about that. So then I put a minus 1 here and a minus 1 here. And I am good to go, because now I set 2 cosine x minus 1 equal to 0, so I can add the 1, divide by 2, cosine x equals 1/2. Here I can just add the 1, cosine x equals 1. And now I go to my trig table or my unit circle, and I find where does cosine equal 1/2? Cosine's equal to 1/2 at pi over 3 and at 5 pi over 3. And where does cosine equal 1? That only happens at x equals 0. So those are my only 3 answers that fall in between 0 and 2 pi. Okay? So I want you guys to try the homework, and you can let me know what questions you have.